Okay, so problem 13 is a really important question. This does come up on the AP, something like this. To assume that an element has a following ionization energy. So they gave you the first five. What you are looking for is where is there a biggest jump between the ionization energies? Well, 600, 1800, 2700, oh, 11,000. That is by far the biggest jump of all the, here, and this is only another like 3,400 jump, all right? So it's between the third and the fourth is where you have the biggest jump. So what does this tell me? It tells me, and think about this, there are three valence electrons, because it will be easiest to remove the three outer shell electrons, and it's going to be very difficult to remove the first inner electron, because you are going to break up a stable filled shell of a noble gas. So what group has three valence electrons? Hopefully you know this is 13. So this comes from group 13 because it takes a huge jump in energy to remove the fourth electron. So the first three, you've removed the three valence electrons. The next one, you're removing the noble gas inner electrons. Okay, I want to show you something. This comes off of an old AP right here. And this is, again, very common to what you might see. So you have these different elements, and they give you the first, second, and third ionization energy. And think about what I've already told you about, what you're kind of looking for. So it says the table above shows the first three ionization energies for atoms of four elements from the third period of the periodic table. So here's a clue. Do you know that periodic table that I told you to look at? Look at the third period. What element starts the third period? Yes, sodium. So you're looking at sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. That's what you're looking at, only those 8. So it says then the elements are numbered randomly. So I don't know which one's which. Use the information in the table to answer the following questions. Which element is most metallic in character? What the heck does that mean? What did we say when we went back over here? Let's go back to this. What did we say? These are your metals, correct? Didn't we say francium is going to lose the electron the easiest, has the lowest ionization energy? That's what a metal does. A metal loses electrons, okay, more easily than non-metal. So which one will lose electrons the most? Okay, the first one anyway. Well, if I'm looking at it, well, which one's easiest to remove the first electron? Well, it looks like to me element number 2. All right, so that would be our answer here is element 2. Why? Because it takes the least amount of energy to remove the outer electron. Identify element number 3. This is what I was telling you. You're removing some, you're removing some more, but look at this is a huge jump between 2 and 3. What does this tell you? It tells you have how many valence electrons? 2. If you're looking at group 3, which is the only element that has 2 valence electrons? Magnesium. Okay. Write the complete electron configuration for element 3. Well, hopefully you can do that by now. Give yourself a little time and do it for me. Notice it said complete. They don't want the noble gas configuration. So you have the 1s2, 2s2, 2p6, 3s2, 12 electrons. What's the expected oxidation state for the most common ion of element number 2? So now we're not talking about 3 anymore, we're talking about 2. Let's go up here. So once again, this is a pretty good jump. That's not as much of a jump. So this is a huge jump. This is your biggest jump right here. So how many valence electrons does it have? 1. Which is the only element in period 3 that has 1 valence electron? Sodium. So what is the most common oxidation state for sodium? It's +1. What's the chemical symbol for element number 2? It's Na. And then finally, which neutral atom of the 4 elements have the smallest radius? Well, we know this is Na. This is Mg. All right, I'm looking at the next ones, folks. We don't have any huge jumps in 1 and 4. So what's my clue? Which one's going to be furthest to the right? The one that has the greatest effective nuclear charge. So is 1 or 4 going to be furthest to the right? I bet 1 is. Okay. So if this one has the greatest effective nuclear charge and they're in the same period, it's also going to have the smallest radius. So it's element number 1. This is a common kind of a question from the AP. So it really brings in a lot of these ideas that we've been talking about. That's why we go over this. So you're going to have more practice on this later, but I hope this has been helpful. This is it for 8.7.